Hey guys, Mr. Gran here, 6.6 Fundamental Theorem of Algebra. So today's stuff is going to be figuring out all real roots of polynomial functions, and then we'll be finding simplest polynomial functions when given irrational and complex solutions. So here we go. Basically, we are going to be solving now the polynomials that are a little too tough to just do by factoring. Okay, we're going to need to use our graphing calculator for these, and we're going to need to use synthetic division. So factoring using synthetic division. This one, technically, we could factor using voodoo factoring, but we're going to attack it. I want to start with a little one to show how to graph this first for you guys to follow along with. So find all solutions and multiplicity of this. The first thing that I'm going to do is I'm going to take this, I'm going to go to my graphing calculator. So get out your graphing calculators. Hit the y equals button. And now mine's got a bunch of them in here because I don't want to spend the time typing all of these because it's kind of time consuming, but I'll show you typing this first one. So if you've got a bunch of stuff in there right now, just move to all of them and use the clear button to clear them out. And then just type in the polynomial as it looks. So this one was 3x squared, so 3, the x button, and then the x squared button, minus this minus, not the negative symbol. Remember, those two things are different. I think it was x and then minus 10. Now, if we go to the graph, it looks like this. Now, mine looks kind of cool because it's all black and green. Yours is a little more drab. But looking at this, I am looking for these points here where the graph crosses the x-axis. These are our solutions. These are our roots. These are our zeros. Now looking at this, I've got one really nice one right here where it crosses right at 2. So this is a nice 0. That's a whole number 0. Those are really important to start with. This one is somewhere in between. I don't know where that one is yet. What we're going to do is we're going to use synthetic division to factor out the factor that this represents and then solve this one algebraically so we have it as a fraction, so we have it as a rational number. So this, remember, if this crosses at 2, that means that x minus 2 is one of the factors that's part of that polynomial, part of its factored form. Okay, so if we go back now, one thing that you should always do with this is let's check our table to make sure that 2 was actually the right solution, because maybe it was just something that was super close to 2 and so it looks like it was 2 on your calculator. So for that, hit the table button, and for whatever reason mine doesn't start where it's supposed to, but yours should start around the middle. If I look at positive 2, the y value is 0. And that's what I'm trying to figure out, right? I want to know what x values make this equation, the output, equal to 0. So that confirms that positive 2 is a good solution. Okay, so what do I do with that? Step 1, we graphed it. And I like to sketch a little graph with these. It's not 100% necessary, but I saw that right here there was a 2, and I know that that means that x minus 2 is one of the factors. That's why this positive 2 works, because you plug it into here and it makes it equal to 0, so it's 0 on the graph. Not sure, though, what this other one is. All right, so the step 2, we're going to factor using synthetic division. So factor all the whole number zeros with synthetic division. Now for this one I only have one, so I'm only going to do one step of synthetic division. The next one is we're going to do multiple steps, so you'll see what that looks like. Okay, so I'm going to start out, we're talking about the factor x minus 2, so I'm going to divide out a positive 2, and our coefficients here are 3, -1, and 10. 3 comes down, 2 times 3 is 6, -1 plus 6 is 5, 2 times 5 is 10. That should be a negative 10 up there, so that our remainder is 0. And that's important. If this is indeed a factor, this will be 0. If you didn't get a 0 here, either this isn't a correct solution, or you did something wrong in the synthetic division. Okay, so now that I've done that, the step 3, we'll write that down here. Step 3 is to solve algebraically. So we're going to solve this. What's left here is a polynomial. It's 3x plus 5, and it's equal. We're going to solve where it's equal to 0. So just like when we were doing synthetic division, right? These numbers represent the coefficients of a new polynomial, the depressed polynomial. All right, so how would I solve this algebraically? Subtract 5 on both sides, right? Just two-sided equation stuff. 3x equals negative 5, and then we're going to divide both sides by 3, and we will get that x is equal to negative 5/3. So our solutions to this, I got a positive 2 by graphing, so x equals 2, and I got a negative 5/3, negative 5 over 3, by factoring and solving algebraically. All right, let's check another one. So I think this one we introduced a little multiplicity, or at least a couple more steps. So a little bit bigger one. We're going to do more than one step of synthetic division. So we'll see what that looks like. It's actually kind of neat, I think. So we'll start out by graphing it. So y equals, and I'm going to be doing this one now, so type that one into your calculator. When you're ready, hit the graph button. And now it looks like this. So it looks like I've got two good solutions here, two nice solutions. It looks like I've got one that I'm not sure on, and then it looks like I've got one here at positive 2 and one here at positive 3. But again, maybe one is just really, really close. So I'm going to go back and I'm going to check my table. And look at that, 2y is equal to 0 at x equals 3y is equal to 0. So I know 2 and 3 are good solutions. So let's take that back here. I like making a little sketch of the graph, so I'm going to do that. How did it even look? Was it like this? And that was at 2, and that was at 3, and this one I'm not sure about. Okay, so I'm going to start factoring them out now. Now, does it matter which one goes first, the 2 or the 3? No, I just always do them left to right. So x minus 2 is a factor, so I'll factor out a positive 2. Bring down the 5. 5 times 2 is 10. Negative 24 plus 10 is negative 14. 2 times negative 14 is negative 28. 25 minus 28 is negative 3. And then 2 times negative 3 is negative 6. So I got a 0 as a remainder. Good, good. And actually at this point, I could also, I know that 2 and 3 are both good solutions, so I can just start writing them, and that's like 2 out of the 3 points probably that are available for this problem. All right, so now, okay, I took out the 2. Now I'm going to take out the 3. I don't need to go back and do it to this whole thing, right? I can actually just take the 3 out of what's left, this depressed polynomial. I already divided out an x minus 2. Whatever's left, that depressed polynomial, I can divide out now the x minus 3 and see what's left. So I just go right into another step of synthetic division right underneath without having to rewrite polynomials or anything. All right, so bring down the 5. 5 times 3 is 15. Negative 14 plus 15 is 1. 3 times 1 is 3. And that leaves me with a remainder of 0. Good, everything's working so far. Always should have zeros for those remainders. Okay, so I took out the 2 whole number zeros. I took out all the whole number zeros that I could find. Whatever's left, now I will solve algebraically. So that is going to be 5x plus 1 equals 0. And now it's just two-sided equation. Minus 1, minus 1. We get 5x equals negative 1. And divide both sides by 5. We get x is negative 1/5. So 2, 3, and negative 1/5. So no multiplicity yet. Multiplicity with the next one. All right, so the next one. Let's load that up into the graphing calculator if you're following along. All right, so for mine, I've already got it loaded up here, this big long one. Hit the graph button, and it looks like this. Looks like I've got one nice one here at negative 4, and a nice one here at negative 3, and then one over here that's kind of in between that I'm not sure about. So let's go to the table and just confirm. Oops. And just confirm that negative 3 and negative 4 are good. So a little bit of scrolling. Negative 4 and negative 3 have zeros next to them, so those are both good solutions. All right, so how did that one look again? Was it like this? Something like that, where this was at negative 4, this was at negative 3, and we were not sure about that one. That one's somewhere in between. All right, so I'll take out the negative 4 first. Again, it doesn't matter. So what I'm really doing is dividing out an x plus 4. I'm factoring out an x plus 4 to try to break this down. 2, 19, 56, 39, negative 36. Also at this point, I could start listing my solutions. So negative 4 and 3. I know those two are good, so I've got 2 out of the 4, right? I know there's 4 total solutions, and I've got 2 of them. So 2, bring that down. 2 times negative 4, negative 8. 19 minus 8, 11. Negative 4 plus 11, negative 44. 56 minus 44 is 12. Negative 4 times 12 is negative 48. 39 minus 48 is negative 9. Negative 4 times negative 9, positive 36. So we're good because we came up with a 0 for a remainder. All right, now we'll do the next one for x plus 3. I'll take out a negative 3. Bring down the 2. Negative 3 times 2 is negative 6. 11 minus 6 is 5. Negative 3 times 5 is negative 15. 12 minus 15 is negative 3. Negative 3 times negative 3 is positive 9. And our remainder is 0. Now I took out the two zeros that I have that I found by graphing, and now I'm left with 3 numbers, right? I can still solve this. This is still a polynomial. We've been doing this for over a week now. This polynomial is 2x squared plus 5x minus 3, and I want to know where it equals 0. So now we've got a case of voodoo factoring. Bring the 2 over to the minus 3, and we've got x squared plus 5x minus 6 equals 0. Actually, I'll take that out since I don't like having the equals 0 on this part since it's that intermediate polynomial. All right, factoring, multiply to negative 6, add to positive 5 would be a plus 6 and a minus 1. And now we'll finish this by dividing both sides by 2. So what I wind up with is x plus 6 over 2 is 3, and then this one doesn't reduce, so the 2 moves in front, 2x minus 1. Well, now we've got one that solves nicely because this is, where is it equal to 0? This one solves nicely where it's just x equals negative 3. That solves this guy, right? And then this guy we need a little bit of algebra for. Some of us maybe are getting to the point where we can just solve these in our head. But 2x minus 1 equals 0. Plus 1 on both sides, we get 2x equals 1. Divide both sides by 2, and we get x equals 1/2. So our two solutions, or our solutions, negative 4, negative 3 that I got from graphing. Then I found a second negative 3 by factoring. So that has a multiplicity of 2. And then also 1/2. All right, so these are big problems, multi-step problems. Try them out, check the keys, rewatch the videos, ask your teachers for help if you're having trouble with stuff, and we'll get through this. These are some of those problems where there's not one particular step that's that tough, but there's a lot of steps in these problems, so make sure that you're getting help if you need it.